Welcome back. All right, so since I haven't received any questions from the previous chapters yet, I shall continue with the next chapter. Guys, have you actually tried doing the questions? Hello? Okay, anyway. We're gonna do numerical solutions of equations. So, I'll just move this here. Right, whenever you see solve in math, what does that mean? It actually means find all the unknowns, right? Solve means find all the unknowns. Oops. So usually you solve it using two methods, one of two methods. The first method is you solve it graphically. For example, if I have, let's say, y equals to x, and maybe y equals to 2x minus 1. If I want to find x, you can graph y equals x and 2x minus 1. And then you find the point of interception, and that is your answer of x. There we go. That's how you solve graphically, right? If they intersect at 2 points, then you have two different solutions, and so on and so forth. Another way of solving something is by doing it algebraically, or you can say you solve it analytically. And very simple example, you equate them together, right? So y equals to, so basically equate, hang on, hello, what's going on? I'm gonna equate this with this guy, and then you get x equals to 1. So there, you have solved it. The graph that I've drawn is, just ignore the graph that I've drawn. It's not accurate because I messed up the diagram, but yeah. So there's actually a third secret method which you do not know, and this is solving something numerically. Oh, so this is what we're going to be doing today. So there are certain questions that cannot be solved algebraically. For example, let's say I ask you to solve e to the power of x equals to 4x. Right? So normally what you do when you try to solve something is you make x the subject and then you get your answer. Yeah? But no matter what you do, you can't make x the subject. So let's say you try to make the x on the right the subject, you will get, oh, something like this. If you try to ln both sides, you would, get x equals to ln 4x. But then there's no way to take out the x inside the ln. So you're always stuck with x as a function of another x. So how are you going to find x then? You can't, right? However, there is something else you can do. So what you want to do is you pick one of the x's. It could be this x here on the left or this x here on the right. You pick one of them, okay? Let's say I'm going to pick x on the right here, and then I'm going to make that the subject. So I'm going to end up with this expression right here. Okay, so from this expression, we can actually split this into two parts, y equals x and y equals to ex over 4. So if you look at these, you actually have two separate equations, right? So imagine if I draw a graph. You don't have to draw a graph in the exam, by the way. This is just to help you visualize what's happening. So y equals x is just a straight line, passes through the origin, and then ex over 4 is kind of like, you know, something like this. And if you can work out what the points of interceptions are, you can work out what the values of x is. So you would have solved x. But then you might be wondering, wait, but if you're drawing a graph, wouldn't that be solving graphically? How are you supposed to solve it numerically? Well, okay. To solve it numerically, this is what you do. I'm going to cut to the chase and show you how to do it first, before I explain how what's going on behind the scenes, okay? So what you want to do is you write x n plus 1. So the n plus 1 is not a power, it's just a subscript, yeah, okay? And then this one you write x n n and then 4, okay? So we're going to say let x1 be equals to 1. So where did this come from? You can actually pick any number you want, it doesn't matter. But if you pick a number close to the root or a number close to the interception point, then you would get the final answer faster. So at this point, it doesn't really make any sense, but just bear with me, okay? So let's say we pick x1 as 1. So what is x2 going to be? Well, x2 is going to be ex1 over 4. All right, x1 is 1. So we put that into your calculator. Where's e? E over 4. Okay, and then you would get 0.67957 dot dot dot. And then you're gonna try to find x3 now. So x3 is gonna be ex2 over 4. You can see that this number here is always going to be 1 smaller than this, because you can see here, this is n plus 1, this is n, right? So this is always 1 smaller. So what is ex2? Well, ex2 is what we found earlier. So it's e to the power 0.67957 dot 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 over 4. And what's that going to give us? Well, let's see. (0.493), and then you keep going. x4 is ex3 over 4, which is 0.409. I'm going to leave it as 4 significant figures. And then x5 is 0.3765. Then you go again, x6 is 0.3643. And then x7 is 0.35987. So usually you want to keep going until the 4th decimal place stops changing, right? So next one is 0.3583, and then x9 is, it's actually a very fast way of doing this, because you can see I'm not putting this equation into my calculator over and over again. I'm just pressing one button, so I'll show you how to do that in a bit. X10 is 0.3575. X11 is 0.3574. X12 is 0.3574. And now you can see that the 4th decimal place hasn't changed, so we can stop now. So if you keep going, eventually you will get the exact answer, but you have to do it an infinite number of times, because this actually takes an infinite number of times to converge to the actual value. But usually in the exam, if you can get up to 4 decimal places, it's good enough. Usually the question will tell you exactly how many decimal places you need to get. Okay, so we get 0.3574. But is that actually the answer? Well, let's find out. So one equation was y equals to x. The other equation was y equals to e to the power of x over 4. All right. As you can see, it intersects at these 2 points here. And one of the points that they intersect at is 0.357. Oh, 0.357. Ta-da! Now, what if I want to find the other root? Because you can see there are 2 intersection points. So to find the other root, if you try to put in another number here, you will always see that it's going to converge to this root. So even if I put in 5 or 6, you still converge to this root. So how do I get the other root then? Well, you have to use the other expression using the other x. So you have to use this one. Okay, so let me just move that here. So that's going to give me xn equals to ln for x, sorry, n plus 1 here, xn. So we're going to say you can pick any number you want, but it converges much faster if you pick a number closer to the root. So you can see the root is 2.15, right? So maybe you can pick something like a 2 or a 3, right? So you could say let x be equals to 2. So at this point, you might be wondering, wait a minute. In the exam, how am I supposed to know what the root is? Like which number to choose, right? Because if we know what the root is, then why are we trying to find the root? So in the exam, usually they will tell you where the root lies, but they're not going to tell you exactly where the root is. But they'll give you a range. They'll say the root is between 2 and 3. So you want to pick a number between 2 and 3. But worst case scenario, they don't give you the range. Then you just pick any number. It doesn't really matter, okay? If you pick a number that is too far from the actual root, it will just take you forever to get there. But by forever, I don't mean literally forever. It just take you maybe much longer than 10 steps, but you still get there eventually, but it just wastes a bit of time. However, there are certain points where if you choose that, you would actually diverge. So you would get a number that gets bigger and bigger, and eventually you get a math error. So if that's the case, just choose a different starting point. Okay, so we're gonna do this again. So let's say 2 is this, and okay, now I'm gonna show you how to do this without taking up so much time, because you would normally have to keep typing ln for x, and then right, you have to keep doing that over and over again. So let me show you a little shortcut that you can do. That's more scientific calculator. Okay, I'll just move that here. So what you want to do is you write 2. Can you see this? Make it bigger. There you go. So you press 2, press equal. Where's there no equal sign? Oh, hang on. Press 2, press equal. Okay. So press answer, that's going to give me 2. Okay, good. So if you want to start with 2, you press 2, press equal, so that it is saved under the answer key on your calculator. All right. Then the next thing you do is you write, do we have ln over here? Yes, put ln and put 4 and you put answer. Instead of putting 2, you put answer in there. Okay, and then you can see if you press enter, you get 2.07.9. So that's what you want to do. So x1 is 2, x2 is 2.079. Okay, We're doing 4 decimal places, so put one more. And you press enter. So usually on your calculator, if you press enter, this would stay there. Okay, so you get x3 is equals to 2.1184. And then you press enter again. And then you would get 137.0. Then you press enter again. You get 2.14. 5, 7. Press enter again. Yes, it is very tedious, but it is what it is. 97. So you keep going until the last decimal, the 4th decimal stops changing. Usually the question will tell you exactly when to stop. They'll say, oh, keep going until the 3rd decimal stops changing, or until the 2nd decimal stops changing. Okay. Yeah, so you keep going until the last decimal stops changing. Yep, and then eventually you get your answer. So there you go, 2.15. And as you can see from here, that is the other root, 2.153. Ta-da! So that's what you do. Okay, now, what exactly is going on behind the scenes? Not sure whether you can actually see this, but oh, it's really small. So tiny. Oh no. Is this good enough? Maybe you should use a different example. Okay, you know what? We'll use a different example because this is a bit too small to show you. Okay. Now, what if we try to solve, let's say, a quadratic, right? Because normally when you try to solve a quadratic, you use the quadratic formula. What if you want to solve the quadratic equation with the numerical technique instead? This one is actually called fixed point iteration. So this technique has a name. It's called fixed point iteration. Right, so let's say we have some quadratic, let's say x squared minus 4x minus 7 equals 0. Okay, so you're going to solve this. So normally if you try to solve this, you would say x is negative b plus minus b squared minus 4ac, so plus 28. Wait a minute, minus 4ac. Yeah, okay. Over 2a. So 4 plus minus 44 over 2. Okay, which is, let's see, what do we get? So 2 plus root 11, or 2 plus minus root 11, which is either 5.32 or negative 1.32. There. Right? What if you want to solve it using the fixed point iteration? Well, first we're going to choose one of these x's. So let's say we choose the second x here. So we're going to make that second x the subject, okay? So we're going to have 4x equals to 7 minus 4x squared. x equals to 7 minus 4x squared over 2. And then we're going to put in the subscript n plus 1. And then this one is n squared over 2. So we're going to choose a value. So let's say let x1 be equals to 1. You can choose any value, but the closer it is, the better, the faster you get there. But for now, we'll just choose some random value. We'll just say 1. Okay, so what are we going to get? Let's use our calculator here. Clear everything. Okay. So we have 1. So we can equal that. So that's our answer. So we have a fraction. Where's the fraction? Where is the fraction? Hello. Seven divided by 2. 7 minus 4 times answer squared. There we go. So we have 1.5. Hey. Right side. Oh yeah. The fraction is over there. Oops. Thanks for that. So next one, what do we have? Next one we have -1. I'm copy pasting the equation here, but in your calculator, all you have to do is press enter. You press the enter sign. Then you can keep going. Not sure whether you can actually see this here. If I go over here, oh sorry, this one. Oh yeah, you can actually see it. Okay, so you want to type 7 minus 4. Okay, wait, answer is 1. So 7 minus 4 bracket answer squared. Okay, this is what you want to do. Can you actually see it? Okay, that's what you want to do. And then once you've done that, you just press enter. You get your first answer, x2, x3, x4. Wait a minute, hang on. Oh no, so this is a problem because it's alternating between the two. So if you get something like this, you want to choose a different starting point. Okay, so sometimes that might happen. So let's choose a different starting point then. Let's choose a... Wait a minute. Did I put in the wrong thing? This is 4x, so it's 7. Oh, sorry, it should be 7 minus x squared. Because this is, there's nothing in front of the x squared here. Hang on. There shouldn't be a 4 here, sorry. Get rid of this 4. I rearranged the thing incorrectly. Okay, so let me get rid of that. Okay. So that's what you want to have. And then we press enter. You get 3, press enter again, -1, enter again. Wait a minute. Did I rearrange this correctly? Oh, it should be divided by 4. What am I doing? Silly me. Okay, there. Okay, so 7 minus this guy squared divided by 4. Okay, so this is what you want to get. And then you want to press enter. Oops. Press enter again, press enter again, press enter again, again. So if you press it enough times, eventually the thing would sort of stabilize. Right? You can see that the first 3 significant figures have stopped changing. Well, the first 4 now, actually. So there you go. So your answer is 1.317. That's how you do it quickly, by just spamming enter. Okay, so 1.317. So one of our answers is negative 1.317. And as you can see, it is very close to the actual value. There you go. I've actually rounded up this guy from this, so that's why it looks like 1.32, but actually it's 1.31 something, 1.317 something. So how do I find the other root then, 5.32? Well, if you try putting 5 into this, or maybe 6 into this, you will notice something, right? Because you can say, oh, if I put 6 into this, would it converge to 5? Well, let's find out. Oh, hang on. So if I put 5 or 6 into that, so let's say 6 is this, minus answer squared. Okay, so I'm gonna go again. So press enter. 4, press enter again. Get this huge number. Enter again, enter again. Oh, negative 13,000. 4 million. It's a gigantic number. And math error. So sometimes this might happen. You might get math error because it sort of diverges. So in that case, just choose a different starting point. Okay. But usually to find the other root, you need to use the other x. So we've used this x here, so now we're going to have to use this x. So if we make the first x the subject, we're going to get x squared equals to 7 plus 4x. X equals to square root 7 plus 4x, and then there's a plus minus here. So we have 2 equations. We can either do xn plus 1 equals to 7 plus 4x n, or we can do, we can do xn plus 1 equals to negative 7 plus 4xn. Okay, so in both of these cases, we just pick x1 equals to, I don't know, 1, whatever. So from the first one, what are we going to get? Okay, from the first one, 7 plus 4 answer. So the first one gives me root 11. Second one gives me 4.502. Then 5.000. 5.196. 5.271. 5.2995. 5.310. 5.314. 5.316. There. You can see this is this. There you go. What if we tried with this one instead? Will we get the same thing? Well, let's see. Negative square root 7 plus 4 answer. If we keep going, we just get math error. Because you can't put a negative in a square root. So this gives me math error, so we ignore this one. There you go. So that's how you find the roots of a quadratic using the fixed point iteration method. Okay, so let's go behind the scenes and show you what's actually going on. So let's say this one here, square root of 7 plus 4x. Okay, is this nicer? Let's see. Oh, this is much better. There we go. Let me just move this here. See if I can walk you through it. Okay, so you can see initially we've chosen wait, what's our initial value? Our initial value we chose 1. Okay, there we go. So initially we chose x is equals to 1. Okay, so if you look at this equation here, you actually have two equations. You have y equals to x. Hang on. Y equals to x and y equals to square root of 7 plus 4x. Right? So y equals x is just the green line here. And then square root 7 plus 4x is this blue line over here. So the point where they intersect is the solution. Okay? So how do we do that? If you take x1 equals to 1, that means you're putting this into this guy here. So when x is equals to 1, what is this function going to be? So imagine you have this point here. This guy is actually 1, right? You can see here. You zoom in a bit. Zoom in a bit more. There you go. You can see this 1. So when x is equals to 1, my blue function is going to give me 3.317. Okay, so 3.317 is actually root of 11. Root of 11. Let me just check. Yep, 3.317 is root of 11. So if you take root of 11 and then you put it back in here, you're actually doing like a horizontal line across. Okay, and then if you take this and you put it back in here to find x3, this one actually go up. And then you're going to find 4.502. There you go, 4.502. And then you put it back in, that means it's going to go horizontally across. And then when you evaluate for x5, it moves vertically up. And you get 5.001, this one. Sorry, x4. And then if you keep going and going and going, you can see eventually it converges closer and closer to the root. So that is actually what's going on. This is an iterative process. You can go on infinitely as much as you want to get as close to the answer as you want, but usually you don't have to do that forever. You just go to some point and you can stop. Okay, so this is what's going on behind the scenes. Okay, right. What about this one here? This one here. Let's try putting this in and see what that looks like. So this one is actually 7 over 4 and then minus x squared. Okay, so this one looks like a cobweb. See? Start at 1, you go up here, you hit the blue line, and then you draw a horizontal line to the green line, and then to the blue line again, and goes boop, 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 and eventually you go over there. Yeah. And what about the part where it sort of diverges? Let's see, where was it? Where was the equation that diverged when we tried to do it? I think it was this one. Yep, this one. So if we choose this one and then we pick x is 5 or 6, it's going to explode, right? So I'm going to show you what that looks like over here. So if we do e to the power of x over 4, and if we choose x is 1, you can see it converges nicely. But if we choose x is, let's say, 5. Oh, you can't actually see it because... Oh, there you go. Oh, it's all the way there. You can see it goes up here. And it can't converge. It just sort of gets there. And then it goes over there. It's ridiculous. Okay, I'm not gonna keep doing. What if you put 4? There. You can see it diverges. It goes poop, poop, and then whoop, all the way to infinity. So depending on the starting value, it might diverge or converge. So yeah, I gotta be aware of that. So if it diverges, just choose a different starting value. Okay? There we go. Now this is actually very useful for solving any kind of equation, really. Even something that is very difficult to solve. Let's say you have some kind of quintic equation. So let me see if I can find an example here. Okay, let's say I give you a quintic equation, x5 minus 5x plus 3 equals 0. And I want you to solve this. Normally, this is impossible to solve using analytic methods because there's such a thing as a quadratic formula, a cubic formula, a quartic formula, so power of 4, but there is no such thing as a quintic formula. So if you have a quintic equation, the only way you can solve this, well, one of the only ways I know how to do it is by using numerical methods, fixed point iteration. So we have two x's, we can make either one of these x's as our subject. If I make the x in the middle as our subject, we would have x5 plus 3 over 5. Okay, so we have xn plus 1 equals to xn5 plus 3 over 5. Let's say x1 is 1. And then we keep going. Just put 1 into your calculator. The power of 5 plus 3 over 5. So 1, 2, 3. So you're just gonna fast forward this a bit. And eventually you get, 0.618. There. See, we've solved a quintic equation. So easy. And what about the other root? Well, the other root is this one. So we can do x equals to 3 plus 5x, and then we take the fifth root. Okay, so eventually, what is that going to give us? Let's say we start with 1 again. So 3 plus 5, 1, and then the whole thing square rooted. Okay, so eventually we get 5.5413. So does this mean the equation only has 2 roots? Is that actually correct then? There's only 2 roots, but this is a quintic, right? So wouldn't you expect there to be more roots? Because quadratic, you have 2 roots, or maybe 1 root, or 0 root. So cubic would be 3, 2, 1, or 0. So quintic could be anywhere from 0 to 5. So in fact, let's check that and see what it looks like. This one is x5 minus 5x plus 3. And as you can see, you have 3 roots. 1, 2, 3. Wait, actually, is there more? No, I think that's it. There's only 3 roots here. Oh, wait. I messed up. This one, I didn't put the 5th root. I put square root. Okay, let me just put the 5th root in here. 5th root. Let's say 1 equals to that. 5th root of 3 plus 5 answer. Okay, so this would actually give me 1.618, which is the golden ratio. Okay. So we have actually found this root, and we have found this root. Wait a minute. Why is it negative? Did I miss a plus minus? Let me think. No, there shouldn't be a plus minus. So why is it that this is negative? Let me check, see. So we have x over here, move that is plus 5x. No, this one. It's plus 5x. Oh, it's plus 5x minus 3. What am I doing? Okay, I messed up. This one should be 5x minus 3. Okay, there we go. Right. So this one is 5. 5 answer minus 3. Okay, there we go. 1.276. So we've actually gotten this root and this root, but we can see that we are actually missing this last root here. So how do we get this root then? There are only two ways of writing this equation, this way and this way. So there's a third root that's missing. Well, if that's the case, that means you are probably, you need to choose a different starting point, okay? So in the exam, you might be thinking, wait a minute, how am I supposed to know how many roots I have if, we're just given this equation? Because this could be anywhere from 0 to 5 roots, right? And how am I supposed to know if I have any missing roots? Well, usually in the exam, they will tell you, they will give you an indication as to how many roots there are. So you don't have to worry about this. So we'll do some examples later, and then I'll show you what I mean by that. Okay, anyway, to find this root, we need to pick something closer to this root here. So let's say we start with -2. So we're gonna do this one. We're gonna start from here, and then we're gonna say x1 is -2, and see whether that converges to our new root. So 5 answer minus 3. And it does. Yay. So eventually you would get x is equals to -1.618. And there you go. You get 3 roots. Okay. If this does not converge, then you just take this this one here and you try it with this equation instead. So, and there we go. Okay. Now, there's also another thing that you have to know when it comes to this chapter, which is how to identify that a root is within a certain interval. So for example, let's pick this quadratic here. So we know for this quadratic, our root is this one and this one, right? So let's say in the exam, they give you this, the question goes like, verify that a root lies between the interval four, 6. Okay, so 4, 6 basically means between 4 and 6, including 4 and 6. If they put bracket, 4, 6, that means it's between 4 and 6, but not including 4 and 6. Sometimes they won't even put the brackets there. Sometimes they would just say between the interval 4 and 6. They write it out in words. Okay. So how do I show that it is between 4 and 6? Well, the way you do that is by starting here. So you equate it to 0. If it's not already equals to 0, you have to make sure it's equals to 0 first, and then you replace the 0 with fx. Okay, so let me just move this up here. So replace the 0 with fx. So now you have fx equals to x squared minus 4x minus 7. So what does this actually mean? This one, you can sort of imagine this is actually two equations. Fx equals to... Actually, never mind. Ignore that part. Okay, so once you've written it like this, what you want to do is you put in x is equals to 4 and see whether you can get 0 or not. So if I put f is not equals to 0 or not, just put x equals to 4 in there and see what you get. Okay, so you're going to get 4 here, and that's going to give you 16 minus 7, so minus 7. And then now you're going to put in 6. So you're going to get 6 squared minus 4 times 6 minus 7, which is 36, minus 24 is 12. 12 minus 7 is 5. Okay, so what you're looking for here is you're looking for a sign change. So you can see here this is negative, but this is positive now, right? So since there is a sign change, you have to write this out in the exam, by the way. If they ask you to verify that there's a sign change, no, they won't ask you to verify there's a sign change. They will ask you to verify that the root lies between the interval. But that is just another way of saying check that there's a sign change. Okay, so you say since there's a sign change, therefore the root is between 4 and 6. So what is happening here? What is going on over here? So let me try to explain this to you. Okay, imagine if I were to sketch this out. And if you look at this guy over here, this is our root, correct? Now, if we take x is equals to 4, x is equals to 4 is over here, our fx, which is our y, is going to give us some negative number. If we take x is equals to 6, however, our y is going to give me some positive number. So if your curve passes through the x-axis, then when you pick these 2 points, there's going to be a sign change, because you can see it goes negative to positive. Whenever there's a root, your curve is going to cut through the x-axis. And whenever it cuts through the x-axis, there must be a sign change. That's why we are looking for a sign change, to show that the root is between those two intervals. Okay? There you go. We can also do the same thing for something like, let's say, this guy here. See this guy? This is Quintic equation. And let's say the question wants you to verify that the root is between 1 and 2. Or maybe the root is between negative 1 and negative 2. Okay? So what you do is you make sure it is equals to 0. And then you put fx in there. And then you put in negative 1 and negative 2. And if the root is between negative 1 and negative 2, you would expect a sign change. So negative 5 plus 5 is, no, negative 1 plus 5 is 4. 4 plus 3 is 7. This one is negative 32 plus 10 is negative 22. Negative 22 plus 3 is negative 19. So there you go. There's a sign change. So sign change, which means your root must be between these two values, negative 1 and negative 2. Okay? Right, so let me show you some more examples. This time we're going to use an actual past year question. All right. Okay, let's do this one. Okay, check this out. So here you're given two curves, 4 cos half x and 1 over 4 minus x, right? And the interval is between 0 and 4. When x is equals to a, the tangents to the curves are perpendicular. Show that a is equals to this. So this one is, so when the tangents of the curves are perpendicular, to find the tangent, you have to do, okay, if they tell you that the tangents are perpendicular, what it means is the gradient of the tangents, the product of the gradients of the tangents must be equals to -1, okay? So the gradient of curve number 1 times the gradient of curve number 2 must be -1. So how do I find the gradients of curve 1 and curve 2? You have to differentiate. So the first one is going to give me, let's see, if I differentiate 4 cos half x, that's going to give me -2 sine half x. Okay. And for the other one, if I differentiate 4 minus x, so this guy is y equals to 4 minus x to the power of -1. If I differentiate that, I'm going to get 1 over 4 minus x and then the whole thing squared. So the 2 dy dx's must multiply to give me -1. Okay, and then this only happens when x is equals to a. So we're going to replace all the x's with a's. And you can see here, they make a the subject. So we're going to try to make this a the subject. So we're going to have, let's see, -2 sine a over 2 equals to, get rid of this negative, 4 minus a squared. So 4 minus a is equals to square root plus minus here, 2 sine a over 2, and then a is equals to -4, so that's going to give me 4 minus plus 2 sine a over 2. And do we retain the negative or positive sign? Well, if you look at the question, they have a negative sign. So hint, hint, wink, wink, you should retain the negative sign. But why do you retain the negative sign and not the positive sign? Well, let's see. What if we get a positive sign here? And a is some positive value. 2 sine of that, square root. Would it arrive at a contradiction? Oh, I would, yeah. So if I put a positive sign, this a is going to be greater than 4. But as you can see from the diagram, a is less than 4. So you can't retain the positive sign. Therefore, this should be a negative sign. There we go. Okay, so this is not the important part that I wanted to show you. The important part is part 2. Verify by calculation that a lies between 2 and 3. So there you go. They've given you the limits, 2 and 3, the interval, sorry, and you need to show that a is between that. So that's the... Okay, so how do we do that? First, what we're going to do is we have to make the whole thing equals to 0. So we have 0 equals to 4 minus square root of 2 sine a over 2 minus a. And then we're going to replace the 0 with fa, not x, because our unknown is a. Okay, and now we're going to substitute in 2 and see what we get. Substitute in 3 and see what we get. Hopefully we have a sign change, because that's what we're looking for. Okay, so we have square root of 2 sine 2 for 2, so it's 1. Make sure it's in radians, by the way. So we get 0.7027. Okay, what about the next one? Next one, we have negative 0.412. Hey, so now you're gonna say, therefore, hang on, not therefore. So you want to say, since there is a sign change. By the way, you have to write this statement out. You have to write this whole thing out, okay? Therefore, A is between 2 and 3. Ta-da! There we go. Okay, then for part 3, use an iterative formula based on the equation in part 1 to determine A correct to 3 decimal places. Give the result of each iteration to 5 decimal places. So if they word it like this, that means you want to keep going until the 3rd decimal place stops changing, because this says here, correct to 3 decimal places, okay? All right, so which value of x, which value of a should you start? Well, we know a is between 2 and 3, so just pick somewhere close to 2 and 3. So let's pick 2.5, okay? So if a1 is 2.5, what is a2? By the way, you should put 2.50000, because each iteration has to be to 5 decimal places right here. Okay. So this is what you should get on your calculator. This is what you should punch in. All right. Then going back here. So A2 is going to be 2.623, sorry, 62233. A3 is 2.60969. So you keep going until the 3rd decimal place stops changing. There we go. So you can see here our third decimal place, which is this this 0 here, has stopped changing. So you can actually stop. Therefore, our A, we have to write it correct to 3 decimal place. So that's going to be 2.611. So that's our final answer. Okay, so that's how you do it. There we go. All right. Shall we do another question? Okay, you know what? Let's do one more question. Let's do this one. One more question. Okay, so you're given the iterative formula and you're given the initial value and it converges to some root, okay? Use the formula to calculate this root. And they want it correct to 4 decimal places. So keep going until the 4th decimal place stops changing. So x1 is 2. Result of each iteration to 6 decimal place. 1, 2, 3, 4, 5, 6. So we start with 2. So make 2 the answer. 2 answer about 6 plus 12 answer divide by 3 answer to the power of 5 plus 8. Okay, so this is what you are expected to get. Okay, so punch that into your calculator. And then push the button. 1.461538. One 1.322 263. One 1.319 508. 1.319 508. Oh, it stopped changing already. So therefore, alpha must be equals to 1.3195. Done. And then part 2, state an equation satisfied by alpha, and hence find the exact value of alpha. Okay, how do I explain this one? Okay, so to find the equation satisfied by alpha, all you have to do is you write this thing again, but you remove all these subscripts. Okay, so you just get x equals to 2x6 plus 12x over 3x5 plus 8. And to find the exact value of alpha, you just have to solve it analytically, so solve it normally without using the iterative method. So we're gonna bring the denominator up. We're gonna get 3x6 plus 8x equals to 2x6 plus 12x. And then we're gonna get this guy here. Therefore, x is the 5th root of 4. There you go. So if you put the 5th root of 4 into your calculator, you would actually get 1.3195. Just to check that you got the right answer. Okay, so that's it, really. That is all there is to it. Okay, so I'm gonna send you guys the questions. If you have the textbook, you can try. Six B. Yep, you can try 6B. 6A is not really important, so you can just skip that. So try 6B, and you can jump straight ahead to the passes if you want to. It's actually not that difficult, just a bit tedious to do. So just do a couple of questions just to get a hang of it, and you should be set. Yeah. Right, so tomorrow is our last class that I will have with you guys. Mr. Zikri will take over in September. So the rest of July and August is going to be our term break, but I think you know that already. So what do you guys want me to do tomorrow? Do you want me to start a new chapter? I could do vectors or complex numbers. It's up to you. You can do one of those, but it's unlikely we can finish the chapter because those two chapters are pretty long. Maybe if I go fast, we can finish vectors, but probably not. Alternatively, if you have any questions, tomorrow would be the last time you get to ask me. So if you have anything from differential equations, integration, this chapter, or maybe differentiation, you can send them to me and then I'll discuss them tomorrow. Okay. So if I don't get any questions, then I'll just continue with a new chapter. But yeah, I think we shall stop here for today. You can try 6B for those with the textbook. And yep, see you guys tomorrow. Bye-bye. Bye-bye.